Hello everyone, here is how I love geometry. I'm Mr. Chao. This problem is 2018 Aime1 problem 4. So let us look at the graph. ABC is a triangle and is a isosceles triangle. AB is 10, congruent to AC, AC also 10, BC is 12. And point D on side AB and point E on the side AC. If we connect DE and it's given the information AD congruent to DE and also congruent to EC. The problem that has to find AD. So this is isosceles triangle and also AD also a isosceles triangle. So normally we talking about isosceles triangle. Let us always think about the perpendicular bisector. I mean, maybe we should do something from vertex A to the side BC, perpendicular bisector. If we say AD, let us suppose ADX, and also here, this is XD, also X, and EC, also X. So AE will be 10 minus X. If we want to find how much for X, we can concentrate on this small triangle, triangle ADE, because x 10 minus x, even though we don't know this angle, but we can find some information about this angle. This angle congruent to this angle, right? Because there's also the angle ABCDEF, let's say AF, also the angle bisector. So this angle BAC also can find his cosine value because we have cosine law, right? In the triangle ABC, we know 3 sides, so we can use cosine law to calculate the cosine BAC, the value of this angle. So we can use this way. I think we can use this way to find the final answer of how much for x. Also, I think here I just want to use, because I say triangle ADE also an isosceles triangle, so I want to get this one, the perpendicular bisector. So this part EFG, so the AG will be 10 minus x over 2. That's the length of AG, right? AG equals 10 minus x over 2. And we know AD is x. So we don't need to know DG. We can use the AG and AD, the relationship between them. We know AG over AD cosine angle BAC. So if I say this is alpha and this angle will be alpha. So because we know cosine alpha in this triangle ABF, right triangle ABF. In this right triangle ABF, we know cosine alpha congruent cosine alpha, right? We know this AB is 10 and BC is 12, so BF is 6, and we know 6, 8, 10, right triangle. So AF is 8. Cosine of equals 8 over 10. I mean AF over AB, 8/10. So that's 4/5. If we know cosine alpha, so we can easily get the cosine 2 alpha, right? Cosine 2 alpha, we can use 2 cosine squared alpha minus 1. Cosine, if we know this cosine 2 alpha, and let us calculate how much for this one. And it's 2 times 4/5 squared minus 1. So 25, 16, 32 over 25 minus 1 minus 25. So how much is 7/25? Now we got this, right? And we know the cosine angle BAC. So this we in the right triangle ADG. Now I will look at the problem like in this small triangle, and in this right triangle we will got this cosine value, cosine 2 alpha, congruent to AG over AD, right? Here. AG, we just know here. 10 minus x over 2 AG over AD. AD is x, right? So it means 7/25 congruent to 10 minus x over 2 here, x. Then we can congruent 10 minus x, here is 2x. Then we can get cross multiplication. 7 times 2x congruent to 25 times 10 minus x, and we will get 14x congruent to 125, 25x, 39x, 15x equals 250 over 39, and we know then MP plus Q congruent here is 0 to 150, 39 equals 289. That's the final answer done. So this problem, I believe we have a lot of different ways to solve it, but this way is not a hard idea, and we just use some basic concept and skill, and it let us to solve it easily. The basic idea, I think, yeah, when we got isosceles, sometimes we just think about the perpendicular bisector of a segment, and then we just use the relationship between the angles. Especially sometimes we can easily to use the double angle formula. That's it. I hope you can enjoy it. Thank you.